Hello students, today we are going to see about materials like concrete and RCC. Okay, so before entering the subject we have to know about the materials used in plain cement concrete and reinforced cement concrete. Okay, so plain cement concrete means it consists of cement, river sand, coarse aggregate and water. So cement, river sand, or fine aggregate, then coarse aggregate, then water. Okay, so nowadays various brands are available in market like Ramco, Sankar, Dalmia. Okay, similarly nowadays we are using M sand instead of river sand due to demand and natural resources. Then coarse aggregate, it is obtained from quarry, various sizes available like 10, 12.5 mm, 20 mm, 40 mm. Okay, but for structural elements we can use 12.5 mm and 20 mm. Okay, structural elements means beam, slab, column, footing. Okay, then water, so the pH value of water should be 7 plus or minus 1, that is drinking water should be used. Okay, so cement, fine aggregate, coarse aggregate, water, which is called plain cement concrete. Okay, then the basically let's see about concrete properties. Basically concrete strong in compression and weak in tension. That means concrete has more resisting power against compressive force, but it has very low resisting power against tensile force. That's why I said strong in compression, weak in tension. The picture shows that compressive force, the blue arrow indicates that compression. Okay, so concrete strong in compression, please keep in mind concrete strong in compression, weak in tension. Okay, so this picture shows that tensile force, the red arrows indicates that tensile force. Okay, okay, so you all know very well about support condition. Okay, this slide shows that a simply supported member. So member means it may be beam or slab having a central point load. When the load acting on downwards, it will bend like this. Okay, and also the fiber in top, that is above the neutral axis, moves towards each other. It is called as compression. Then the fiber in bottom, that is below the neutral axis, moves away from each other. It is called as tension. Okay, so this picture indicates that we all know concrete weak in tension. That's why cracks will form in tension side, that is bottom. Okay, so the structural member will bend like this while load acting on it. This figure exactly shows that the fiber move when the load acting on it. The blue line indicates compression and red arrows indicates tension. Okay. Here the dotted line mentioned that neutral axis, here compression and tension equal to 0. Okay, compression and tension equal to 0. That neutral axis above the fibers, all the fibers have compression. The below the neutral axis, all the fibers below the neutral axis have tension. Okay, so while applying the tensile force, concrete weak in tension, so cracks will occur like this. So in order to overcome the tensile failures, we have to provide reinforcement in tensile zone, that is bottom. So next concept is how do you resist the failure in concrete due to tension. Okay, so this is the reinforcement available in the market. So this picture shows that a simply supported beam is loaded at 2 point. After loading, this beam will bend like this. So keep in mind, this is PCC beam, plain cement concrete beam. Reinforcement is not provided. That's why cracks will form easily and tensile zone. That's why the cracks will form easily at tensile zone and collapsed suddenly like this. When we provide reinforcement at tensile zone, the cracks will be like this. Sudden collapse is not happened. Okay, so RCC means cement RCC means reinforced cement concrete, which contains cement fine aggregate, that is river sand, either river sand or M sand, coarse aggregate, water, and reinforcement. Okay, this is called as reinforced cement concrete. Then let's see the grade of concrete, like M10. Various grades are available: M10, M20, M30, M40, like this. Here M indicates mix. Here M indicates mix. 10, 20, 30 are characteristic compressive strength, which denotes FCK expressed in Newton per mm square. So characteristic compressive strength means 20 samples, that is cubes, size of 150 by 150 by 150 mm is casted. Then it is PCC. Okay, it is not RCC, it is PCC because cube, so reinforcement will not be provided. Then it will be tested after 28 days curing. The 5% of test results expected to fall, that is 15 cubes out of 20. 15 cubes have got design strength, 5 cubes have not got design strength. That strength is called as characteristic compressive strength. Okay, So the cubes are tested in compressive testing machine, that is CTM machine. So after applying load, it will be collapsed. So finally uh, the readings will be captured or noticed at what kind of load that cubes are collapse will be noticed. Okay, so this is the characteristic compressive strength. So this is the various grade of concrete and its compressive strength. So here please notice that, so greater than M60, like M60, M65, M70, 75, 80, those grade of concretes are called as high strength concrete. Okay, so a lot of projects are going on high strength concrete. Next, let's see grade of steel. So there are classified into two categories according to carbon content. One is plain bar, another one is tar steel or HYSD bar. Okay, so plain bar is nothing but Fe250. Okay, then tar steel and HYSD bar is nothing but Fe415 and Fe500. Okay. HYSD means high yield strength deformed bar. Okay, here Fe indicates iron, 250 indicates yield strength or tensile strength or tensile strength. So this is various diameter available in the market, like 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, 25 mm, 32 mm diameter. So this picture shows that a simply supported beam, when a simply supported beam is subjected to uniformly distributed load, the cracks will occurs. Okay, so here's various cracks, there is various cracks due to various aspect. Okay, so cracks due to, there is two categories, one is cracks due to shear, another one is cracks due to bending. Okay, so cracks due to bending means it occurs due to tensile force. Okay, then cracks due to shear will occur due to shear force. Okay, so cracks due to shear prevented by stirrups. Keep in mind, cracks due to shear prevented by only stirrups or bent up bars. Okay, then cracks due to bending is prevented by tensile reinforcement. Okay, so this is the stirrups or shear reinforcement. So this is the reinforcement for providing or for providing to prevent the cracks due to shear force. Okay, this is the arrangements of reinforcement. This is the stirrups shape. Normally 8 ohm dia bars used in beam. This is the beam column reinforcement. See, the bottom reinforcement is tensile reinforcement in beam. The top reinforcement is also called as compression reinforcement or hanger bar. Okay, In column, the vertical reinforcement is called as longitudinal reinforcement. Then the rings is called as ties, whereas beam, the rings is called as stirrup. Okay, and we are using two code books for RCC design. One is IS 456 2000, another one is SP 16 1978. Okay, so here IS means Indian standard, so a lot of standard specifications are referred in these code books. By practical experiences, the government quoted all the specification related to RCC design, so we can refer it. Okay, so IS 456 1978 means it is the earlier one. It is based on working stress method. Nowadays the structural members or structural elements are designed by only limit state method, not in working stress method. But in your curriculum you have to study about working stress method. Okay, so and also IS 456 2000 based on limit state method. Okay, nowadays all the structural members are designed by only limit state method, not in working stress method, but except water tank. So nowadays water tank is designed by working stress method. Okay, so this is the code book picture. Okay, so this is the introduction about the materials like concrete and RCC, grade of concrete, grade of steel, like that. Okay, so keep in mind this is the most important subject, so you have to learn very carefully. So whoever going to work in construction site, so having good knowledge about this subject, then only you can withstand in construction site. Otherwise, you will not be stable in construction site. Okay, so keep in mind it is very interesting subject where so work out or study very carefully. Thank you very much. Thank you.